When we look up at the night sky, we see thousands of tiny points of light. Yet each of these points is a nuclear furnace large enough to swallow our entire planet. So, how do these colossal plasma balls, including our own sun, come to be? How do they live? And most importantly, how do they die? The fate of every star is determined by its mass at the moment of its birth. And when the most massive stars perish, one of the most terrifying yet most beautiful events in the universe occurs. This is the incredible life cycle of a star. Birth and power source. Stars are born in nebulae, vast clouds of gas and dust in space. In a dance lasting billions of years, gravity forces this cloud to collapse in on itself, heating it and forming the protostar. The single thing that makes a star, nuclear fusion. When the core temperature reaches 15 million degrees Celsius, the laws of physics are bent. Hydrogen atoms fuse together, releasing an immense amount of energy and creating helium. This is the secret to a plasma ball constantly burning itself. A star's life depends on a delicate balance between the outward force of fusion and the inward pull of gravity. As long as this balance is maintained, the star remains in its peaceful phase, called the main sequence. Mass decides the destiny. A star's color and brightness tell us its temperature. Blue stars are the hottest and burn through their fuel quickly. Red stars are cooler and can burn slowly for trillions of years. But the most critical factor that determines a star's entire destiny is its mass. Small mass stars, like a red dwarf, can live longer than the universe itself. But giants that are 8 times more massive than our sun, they are only a few million years away from a cosmic explosion. The end of our sun. So, what will happen to our sun, the source of our life? In about 5 billion years, the sun will have completely exhausted the hydrogen in its core. Its outer layers will start expanding uncontrollably, transforming it into a red giant. It will swell large enough to engulf Mercury, probably Venus, and even the Earth. Eventually, its outer layers will slowly drift into space, leaving behind a core that shines like a diamond, but is destined to fade completely. A white dwarf. This end is relatively calm, but for massive stars, the story is entirely different. Cosmic catastrophe, supernova. Stars more than 8 times heavier than the sun consume their fuel much faster, pushing the elements to the next stage, carbon, neon, oxygen, until the core begins to produce iron. Iron cannot fuse. This is the final end that breaks the balance. Gravity suddenly wins, and the star implodes in less than a second. The result? A supernova, one of the brightest explosions in the universe. A supernova can emit as much light as an entire galaxy, scattering all of the star's elements into space in seconds. The gold, silver, iron, and carbon in your body, all of it is the remnant of a supernova that died billions of years ago. We are, quite literally, stardust. Monsters born from death. After the supernova, 2 terrifying cosmic legacies remain. If the remaining core is massive enough, an incredibly dense neutron star forms. A teaspoon of its matter weighs more than Mount Everest on Earth. But if the mass is even greater, gravity allows nothing to escape. That's when the ultimate monster that tears the fabric of space-time itself is born: the black hole. This is the most dramatic end to a star's life. Mass turns it into either a dense sphere or the universe's deepest well. Conclusion: beyond the answers. Every single point of light is a billion-year-old story, a power source, and a chemical factory. As stars die, they throw the building blocks of life back into the universe. So the next time you look up at the sky, remember you are not just seeing light, you are seeing where life began. How terrifying do you think a supernova could truly be? Share your thoughts in the comments. Don't forget to subscribe and turn on notifications for more cosmic adventures.